These are examples for section 14.3 pyramid and cone surface area. Example 1. What is the total surface area of the hexagonal pyramid shown at the right? Express your answer as an approximation rounded to the nearest tenth of a square inch. Here we have a hexagonal pyramid with its vertex here. And so the surface area of any pyramid is surface area is equal to the lateral surface area plus the area of the base face. In this particular case, the base face is a regular hexagon, so the base face area formula for that is 1/2 times the apothem times the perimeter. We're at a regular hexagon where n is 6. So the surface area gives us the lateral area is 1/2 times the perimeter of the base times the slant height. They give us the slant height here, which is 9 inches. And our perimeter we can find using P equal NS, since we have a regular polygon. So the perimeter is the number of sides, which is 6, times the length of a side, which is 6 inches. Therefore, our perimeter is 36 inches, the perimeter of the base face. Plus, big B, or is the area of the hexagonal base, is 1/2 AP, where A is the apothem. The apothem is given to us right here, 3 times the square root of 3 inches from a side perpendicular to the center of the polygon. So A is 3√3 inches. And we already have our perimeter. So we have everything we need to substitute into this. So the surface area of this cone is 1/2 times the perimeter, which is 36 inches, times the slant height, which is 9 inches, plus 1/2 times the apothem, which is 3 times the square root of 3 inches, times the perimeter again, which is 36. We have two terms here, the one there and one here. We can take half of 36, 2 goes into 2 once, 2 goes into 36 18 times. Over here also 2 goes into 2 once, 2 goes into 36 18 times. Getting rid of our fractions, we now have 18 times 9 plus, now we have 3 times the square root of 3 times 18. Now we can multiply the numbers in each term. We have 162, 18 times 9, plus 3 times 18 is 54 times the square root of 3. This would be the exact surface area of this pyramid, the base, and all its triangular lateral faces together. And that would be in square inches. They asked for an approximation rounded to the nearest square inch. So in our calculator, 162 plus 54 second square root 3, get out of the square root, enter. We have about 255.5 square inches. Example 2. The pyramid of Cestius is located in Rome, Italy. Using the dimensions in the figure below, what is the lateral area of the pyramid rounded to the nearest square meter? It makes sense that we're looking for lateral area here, since the base of this pyramid assumably is on the ground, and so we're looking at everything outside on the pyramid. This was designed after the Great Pyramids in Giza, Egypt. So here, let's take stock of what we have. We've got the height of the pyramid, the actual height, not the slant height, but the height is 36.4 meters right here because it's perpendicular to the base face. We also have one of the sides of this square prism, or pyramid, which is 30 meters. We assume that all bases of pyramids and prisms are regular polygons, so that's why we know this is a square. 30 by 30 by 30 by 30. We also we have the slant height indicated here, but we don't have the length of it, so we'll have to find that. So if we're finding the lateral surface area, that's LA for a pyramid, is 1/2 times the perimeter times the slant height. Well, for the perimeter of a square, of course, is 4 times the length of one side. So the perimeter is 4 times the length of one side, which is 30 meters. So the perimeter is 120 meters. Next, trying to find L, the slant height. We take a look, notice that our slant height is part of a right triangle inside the pyramid, and we've got two of the two leg lengths creating the right triangle. Since we have both of them, since this is 30, this would be half as much, which would be half of 30, or 15. So this is 15 from C to A, half the length of the base length here. So we can use the Pythagorean theorem here. Where L, or AB here, L, the slant height, is the hypotenuse. So we have L squared is equal to AC, or 15 squared, plus the length of BC, the height, or 36.4 squared. Then we have L squared is equal, this is the slant height, 15 squared is 225, plus, then when we square 36.4, we get 1,324.96. Adding those two together, L squared is equal to 1,549.96. To solve for L, we take the square root of both sides, and so L is the square root of 1,549.96, and so this is what we're going to use, this exact amount. Place it in for our L. So we have everything we need here. We have our slant height and our perimeter. So coming back over here, the lateral surface area is 1/2 times the perimeter, which was 120 meters, times the slant height, which is exactly the square root of 1,549.96. At this point, this is all one term, so we can take half of 120, so 2 goes into 2 once. 2 goes into 120 60 times, so our lateral area then now is 60 times the square root of 1,549.96. At this point, we use our calculator since we have this irrational square root, and we put in 60 times second square root 1549.96. Get out of the square root, press enter, and you should get about 2,362 square meters. This is how much surface area is on the outside of this pyramid of Cestius in Rome, Italy, on all 4 sides, lateral faces of the pyramid. Example 3. What is the total surface area of the cone in terms of pi? Here we have a cone, circular base, and we're given the radius. The radius of the cone is 15 centimeters. We're also given the slant height of 25 centimeters. This is the slant height. This is the actual height, which is perpendicular to the base face. And so we have 25 for a slant height. This is all we need. So the formula for the surface area of a cone, that includes everything laterally and on the bottom also, this base, is the lateral surface area plus B. Not 2B, but B. There's only one base. And so let's go ahead and define what LA and B are. In a cone, LA is pi times the radius times the slant height, pi RL, plus the area of the base. This time, big B is the area of a circle, pi r squared. So we use pi r squared here. Then substituting in our values, the surface area is pi times the radius, which is 15 centimeters, times the slant height, which is 25 centimeters, plus pi times the radius, which was 15 squared. We have two terms here, separated by an addition sign. Using the order of operations, we can multiply all of this together. We're going to leave pi. So far, we have 15 times 25 is 375 pi, plus 15 squared is 225 times pi. We treat pi just like we do variables. 375 pi plus 225 pi gives us exactly 600 pi. So the exact surface area in terms of pi for this cone, the outside of it, including the base face, is 600 pi square centimeters. Example 4, chemistry. In a chemistry lab experiment, you use the conical filter funnel shown at the right. About how much filter paper do you need to line the funnel? Now the funnel itself is this cone right here. We're given that the diameter of the circular base of the cone is 80 millimeters and the height, the literal height, is 45 millimeters. Now, it doesn't say what kind of surface area to find, but the filter itself is open, so therefore we're going to find lateral surface area because we're not going to include the base. So the lateral surface area of a cone is pi times the radius times the slant height. And this time we're not given the slant height directly, but we do have the height, which is perpendicular to the base, the circular base. And since the diameter is 80 millimeters, the radius would be half of that. So we take the radius, or the diameter, 80 millimeters, divided by 2. We get 40 millimeters for our radius. So from here to here, of course, is 40. And then the height of the cone, from the base to this vertex here of the cone, is 45 millimeters. So we can use Pythagorean theorem with this right triangle right here and find the slant height. The slant height would be this length from here to here. So we have our right triangle where L is the hypotenuse, so the slant height squared equals 40, one of the legs, squared, plus 45 squared. Solving for L squared, 40 squared is 1600 or 1600 plus 45 squared is 2025. Adding those together, we get L squared equals 3625. Solving for L, we take the square root of both sides. Those cancel each other out, and L is equal to the square root of 3625. Now you could simplify this, but since we're using it in our formula here, I'm just going to keep it in this form right here. So we have our L and we have our radius. Everything we need. We plug it in here. We have pi times the radius, which is 40, times the slant height, which is exactly the square root of 3625. Leaving pi and leaving the square root, this is about all we can do. If you want, you can put 40 first and write it like this. It doesn't really matter, because at this point it says about how much filter paper do we need. So we do an approximation, taking our calculator. We have 40 times second pi times second square root, 3625. Get out of the square root, hit enter. You should get about, rounded to the nearest ones place, or square millimeters, 7,566 square millimeters. Now the reason why I didn't round to the tenths is because we don't need something quite that small. So 7,566 square millimeters is a good, very close estimation of the actual surface area of the filter. Example 5. Now for some composite work. Find the total surface area of the composite figure at the right. Write your answer in terms of pi and as an approximation rounded to the nearest whole number. Here we have a cylinder that's connected to a cone. The cone and cylinder share one of the bases. In fact, for surface area, this base right here in both of the figures is not going to be included in the surface area because it's inside the composite solid. So all we have here is this base. We've got the lateral part of the cylinder and only the lateral part of the cone. Once again, we've got one base of the cylinder, just one base, and its lateral part and only the lateral part of the cone. This is not in our calculation. So, the surface area of the composite, then, what we can do, there's a couple of ways you can do this. One way we can do this is take the lateral area, surface area of the cylinder. So that would be everything but this base here. And it wouldn't include this either. Add this base right here, because we need that base, and I'll just write B for base, and of course that's the base. I'll call it base 1. Write B1 in here. Then, after we do that, we can add the lateral surface area of the cone. So that's our general formula. Writing a more specific formula, we go back to our formulas for cylinder and cone surface areas, lateral. And this lateral surface area of a cylinder is 2 times pi times the radius times the height. Now this is the height of the cylinder. The height of the cylinder is 6 feet. And the height of the cone, however, is 12 feet. So we have to distinguish between those two. So this would be the height of the cylinder plus the base face area, which is a circle. So it's pi r squared. Plus the lateral surface area of a cone. Formula for that, again, is pi times the radius times the slant height. So this would be a working formula we could use to find the surface area of this entire composite figure. Then, let's see if we have everything we need. We have the height of the cylinder, and we're not going to need the height of the cone directly. We're going to need it to find the actual slant height, though, because the slant height is this right here. So we'll need this, and we'll also need the radius, so we can use a right triangle and Pythagorean theorem. So let's do that down here. By Pythagorean theorem, this is to find the slant height. We have the slant height squared equals the height of the cone, which is a leg of the triangle, 12 squared, plus the radius of this cone, which is the same as the radius of the cylinder, which is 5 squared. So meanwhile, let's put our radius over here is 5 feet. And continuing on with our slant height, solving for L eventually, we have L squared equals 144 plus 25. L squared is equal to 144 plus 25 is 169. Solving for L, we take the square root of both sides, and the square root of 169, that is a perfect square, gives us 13. So our slant height is 13 feet. So we have our radius, we have our height for the cylinder, not the cone, and we have our slant height. That's everything we need. So we substitute all of that in. We have 2 times pi times the radius, which is 5 feet, times the height of the cylinder, be careful, the height of the cylinder is 6 feet, right here, plus pi times the radius, again is 5 squared, plus pi times the radius once again, which is 5, times the slant height, which we found is exactly 13. So we have 3 terms here separated by 2 addition signs, here, here, and here. Using the order of operations, we can multiply all this together except for the pi. We have 2 times 5 is 10, 10 times 6 is 60 pi. Plus 5 squared is 25 times pi. Plus 5 times 13 is 65 times pi. All 3 of these terms are pi terms, so we can add all 3 of them together. So the surface area, the composite surface area of this figure, the exact amount, is 60 pi plus 25 pi plus 65 pi, which is exactly 150 pi square feet. There's our first answer. An approximation, rounded to the nearest whole number, that's the nearest square foot. 150 times pi, which gives us 471 square feet. That's an approximation. Example 6. A rectangular yard is enclosed by a white picket fence. The homeowner wants to paint the 4 corner posts plus 2 gate posts the same color as her house. She knows that a quart of paint, 1 quart, covers 100 square feet. But she doesn't know if 1 quart will be enough for 2 coats of paint on all 6 fence posts. So we have 6 fence posts. How many quarts of paint should she purchase if she paints on 2 coats? So there's quite a few things that we need to do here. First of all, take a look at a picture of one of the pickets. We're going to paint 4 of these, or 6 of these. So we have, looks like we have a pyramid up here at the top, a square pyramid. So the cap is a square pyramid. And then the post itself is a prism. Looks like a square prism because it's 5 7/8 all the way around each side. So the post, or a post, is a prism or a square prism. So we're going to use pyramid and prism here. Next, take a look at our dimensions. We have 3 inches. This is a slant height here. We have the height of the post is 40 inches, and then we've got the length of each one of the sides there is 5 7/8 inches. Now, because we're painting, and this isn't some very large job or something that has to be horribly precise, we're going to go ahead and say, hey, 5 7/8 is really close or fairly close to 6. It'll make our math easier, and it's not necessarily we'd be that precise. So I'm going to go ahead and change that to 6 inches. Now we've got a square that's 6 by 6 by 6 by 6. Okay, next thing we notice is eventually we're going to have to talk about how much to cover. So we know that 1 quart of paint will cover 100 square feet. So we write that down to remind ourselves 1 quart paint is going to equal or be the same as 100 square feet. Next, we're going to find the surface area, starting with 1 post, just focusing in on 1. We're going to find the surface area of the pyramid without its base, because the base is in between the pyramid and the post. We're obviously not going to paint it. So we have the pyramid's lateral surface area, and we also have the lateral surface area of the post. And because neither one of the bases will we paint. We're not going to paint underneath. That doesn't make any sense. And we don't paint on top because the pyramid's on top. So we can come up with a general formula. The surface area of this composite, this 1 post, is the lateral surface area of the pyramid, right here, plus the lateral surface area of the prism right here. Now, because we're going to have 6 posts all together, there's 4 corner posts and 2 gate posts, that's 6. We're going to take all of this and multiply by 6. So, let's go ahead and find our detailed formula for both these two lateral surface areas. Don't forget your 6, and then we have times. The lateral surface area of a pyramid is 1/2 times the perimeter times the slant height. Remember, this is a pyramid, not a cone. Plus, the lateral surface area of a prism is simply the perimeter times the height of the prism. Next, to make our math a little simpler, notice what we can factor out of this right here. Now, you don't have to factor anything out, but you can. Notice that P factors common to both of these terms. So I'm going to take the P out, and now I have 6P times 1/2 times the slant height plus just simply H. So this would be a formula, or the formula we're going to use, at least to begin with. Now later on, we're going to have 2 coats. We're going to end up multiplying this by 2. You can multiply this by 2 right now if you want to, or you can wait. I'm going to wait. Next, we define our variables here. So we come back over here to our post, and first of all, the perimeter of both the pyramid and the prism is a square. So we use 4s, 4 times the length of a side. We've approximated the side, so the perimeter is approximately 4 times the length of a side, which is about 6 inches. This gives us a perimeter of about 24 inches, both for the prism and for the pyramid. Next, we need the height of the prism, which is right here, 40. So the height of the prism is 40 inches. Now, we don't use the height of the pyramid, but we do use the slant height of the pyramid. The slant height of the pyramid is 3 inches. L is 3 inches. Now we have everything we need right here to use in our formula. So substituting these values in, we have 6 times the perimeter, which is about 24, times 1/2 times the slant height, which is 3, plus the height of, that's the height of the prism because it came from pH, and that was 40. Next, we start simplifying this, and 6 times 24, we get 144 times, and here I'm going to notice that 2 doesn't divide out with 3, and it can't divide out with 40 because we're adding here. So this is 3/2. 1/2 times 3 is 3/2 plus 40. I'm going to leave this in fraction form. This is 144 times 3/2, and finding a least common denominator of 2, this would be 40 times 2, which is 80. So now I have 144 times 3/2 plus 80/2 is 83/2. Now notice the 2 is the 83/2 is multiplied with 144, so we can take the 2 and divide it out with 144. 2 goes into 2 once, 2 goes into 144, exactly 72 times. So now we have 72 times 83. Multiplying those two together, we get 5,976 square inches. Now, this is the surface area of all 6 posts. All 6. That's how much paint we're going to need for all 6. Now, we're going to put 2 coats on it, so we're going to multiply that by 2. And that gives us 11,952 square inches. Okay. At this point, we're not done because we've got square inches and we need square feet. So we're going to look back at what we did in the last unit where we took different kinds of units, area, perimeter, and K, the scale factor. And we're going to remember that there are exactly 12 inches in 1 foot. But we're also going to have to remember that we're using square feet. So to start off with, we write the number of square inches we're using, 11,952 square inches. We're going to multiply that with a conversion factor so that we can get it into square feet. However, we do use this. We want inches to cancel, so inches are going to go down here. So I have 12 inches down here, and I have 1 foot up here. However, notice that there's 2 inches up here, 2 factors of inches up here, and only 1 factor of inches down here. This has to be squared. So what we can do is we can square this entire ratio. When we square this ratio, we must square the 1, square the feet, square the 12, and square the inches. Everything gets squared. So now we have 11,952 square inches times 1 squared is 1, feet squared is square feet, 12 squared is 144, and inches squared is square inches. So now this is our new conversion factor that we use with area. At this point, the inches squared divide out or cancel out, and we multiply the numerators and the denominators. We get 11,952 square feet over, and then just 144 because the inches squared is gone. Now we take 11,952 divided by 144. It gives us exactly 83 square feet. So this is how much this is how many square feet we're going to cover in our painting all together. One last thing we need to do, we need to use this right here. We need to figure out how many quarts we're going to use. 1 quart will cover 100 square feet, so we create a proportion. Now, this is one of our ratios, so there's 1 quart will cover every 100 square feet. And we set another ratio up in our proportion, quarts to square feet. We have 83 square feet, so we put it down here, and we're looking for how many quarts that's going to give us, or we're going to have to use. Cross multiply, we get 100x equals 1 times 83 is 83. Divide both sides by 100, and x is 83 hundredths of a square foot, or excuse me, quarts of paint. So we don't need quite 1 quart according to this. So to answer the question, how many quarts of paint should she purchase if she paints two coats? She's only going to need 1 quart of paint. She's only going to need to buy 1 quart of paint. And that's your final answer. Example 7. Find the slant height L of the given cone, given that the total surface area of the cone is 36 square feet. This time they're giving us the actual surface area of the cone. So they want to know the total surface area. So for the total surface area of a cone, we have LA plus the base face area, which is a circle, of course, here. Radius is not 8, it's half of that, so the radius is 8 feet, the diameter divided by 2, which gives us 4 feet. There's our radius. Surface area, the lateral area, surface area of a cone is 1/2. Excuse me, not 1/2, it's pi r/L. Pi times the radius times the slant height, plus the area of the base face, which is pi r squared. So plugging in or substituting in everything we know, the surface area total is 36, so we plug that in here. 36 pi, sorry. 36 pi equals pi times the radius, which is 4, times the slant height. So we need the slant height, which they gave us was 5, plus pi times the radius, which is 4 again, squared. Please disregard that first attempt at example 7. I gave away the answer, didn't mean to. So let's start over. Example 7. Find the slant height L of the given cone, given that the total surface area of the cone is 36 pi square feet. So they give us the area, the surface area, the total surface area here. So I'll write that here. The surface area of this entire cone is 36 pi square feet. They also give us the diameter, which is 8 feet, the circular base. So to start off with, we know we're dealing with surface area of a cone. So the surface area is the lateral surface area plus the area of the base face. In this case, big B is a circle, so it's pi r squared. The lateral surface area of any cone is defined by the formula pi times the radius times the slant height. Then we have plus big B, which is the area of the circular base, pi times the radius squared. So we have this formula right here. We can factor out not only pi here, but we can also factor out one r factor. There's one here and two here. So let's go ahead and plug in the 36 pi square feet for the surface area. We have 36 pi equals, and then let's factor out pi and r. Now, you don't have to factor these out. It just makes it a little easier later. We have what we have left here is L plus, and then we have just one r left here. Now, let's go ahead and define what we do have here. The diameter was 8, so the radius is 8 feet, the diameter divided by 2. So the radius is 4 feet. So there's one of our variables. We already have the surface area, and that's all we need. So we have 36 pi for our surface area equals pi times the radius, which is 4, times, in parentheses, the slant height, which we're looking for, plus the radius, again, which is 4. So we have 36 pi equals 4 pi times, in parentheses, L plus 4. Now, since we're looking for L, we need to get rid of everything around L. L plus 4 is being multiplied with 4 pi. So 4 pi, or 4 and pi, are both factors. We can divide both sides by 4 and by pi, like that. And the 4's here divide out, the pi's divide out, and we're left with L plus 4. On the left side, the pi's divide out. 36 divided by 4 is 9. Now all we need to do is solve this one-step equation by subtracting 4 from both sides. When we do that, we get L is 5. So our slant height is 5 feet. We found the slant height of this cone by using its surface area and its radius.